Hi there, and welcome back to another Papetti Math YouTube video tutorial where I'm going to be teaching you, yes, you, Algebra 1. And in this video, we're going to be looking at different exponential growth and decay functions. We're going to be determining if they're growing or decaying, and then we're going to state what the percent growth or decay is. So given these 6 functions, let's take a look at one at a time and see what we can do with each of them. So we know that f of x is equal to 500 times 1.22 to the x. And this looks like the form y equals a times 1 plus or minus r to the t power, which is our general form of a exponential or decay, our exponential growth or decay formula. Blah, tongue twister. Not really. So we have this formula here. And we see that our initial amount, or our y-intercept, is going to be 500. But what we're concerned about is what's inside the parentheses, because we need to determine if it's growing or decaying. And if we're multiplying a number by a number that's larger than 1, it's going to make the original number larger. We should know that. So again, if the number inside the parentheses is greater than 1, our function is growing. That's how we're going to know it. If the number is larger than 1 inside the parentheses, it's growing. So this is growth. And what's the percent growth or decay? Well, we're looking at what's being added on to 1. So how much greater than 1 is this? And it's 0.22 greater than 1. And 0.22 as a percent, we're going to multiply by 100 to get 22%. So our answer here is that this is undergoing 22% growth. Because again, that's what's being added on to our R value, our 1, what's being added on to 1, excuse me. So in part B now, we're looking inside those parentheses, and we see that we have 1.06. Again, it's greater than 1, so it's growing. So we know it's growth. And it's growing. It's what's being added onto 1 there, 0.06. So we have 0.06, and again, we're going to change that to a percent. That's going to give us 6%. So this one right here is going through 6% growth. Because again, we know that we're adding 6% onto 1 inside these parentheses. If we're looking at part C, on the other hand, now we have a number that's less than 1. And if we multiply any number by a number that's less than 1, we're going to get a smaller amount than what we started with. So this is one of the cases where we have y is equal to a times 1 minus r to the t. So we have to look at this and see what are we subtracting from 1 to leave us with 0.95. And that's going to be 0.05. 1 minus 0.05 will give us 0.95. And to change this to a percent, we multiply by 100, and that's going to be 5%. And in this case, since we're subtracting it, it's going to be 5% decay. So this function is decaying by 5%. Also, the way I like to think about it is if you have 95% inside your parentheses, what percent are you missing? Well, 5%, of course. All right. So now we have 985 thousandths in this parentheses. And so we're clearly missing something from 100. And what are we missing? Well, we're missing 0.015 in order to make that 100. This is really 98.5%. And what percent is missing to get to 100? And that's going to give us 1.5%. And again, we're subtracting 1.5% from 100 to leave us with this 98.5% inside those parentheses. So it's decay. So we have 1.5% decay in part D. Let's take a look now at part E. In part E, we don't have an original amount, but we did look at functions in the form of y equals b to the t in lesson 3 and 4. Actually, lesson 4, I believe. And that means that our y-intercept is just going to be 1. So this is really 1 times 1.2 to the t, where 1.2 is our growth or decay. So inside these parentheses, It's a number larger than 1, so it's growing. So this is going to be growth right here. And how much larger than 1 is it? Well, it's 0.2 larger than 1. And if we convert that to a percent, we're going to get 20%. So this right here, this function right here, represents 20% growth. And our final one, p of x is equal to 7,000 times 0.88 to the power x. We're going to notice that inside those parentheses, it's a number less than 1. And how much less than 1 are we? And 0.88, well, 1 minus what will give you 0.88? And that's going to be 0.12. And 0.12 as a percent, obviously, is going to be 12%. So this problem right here, this function represents a 12% decay. All right. So just by looking at these functions, looking at their growth factors, the number inside the parentheses, we could determine their growth or decay rates. Let me say that again. Just by looking at their growth factors, remember the factors, the whole number inside the parentheses, we can then determine the growth or decay rates. That's what's being added or subtracted onto or from 1 inside those parentheses. So the entire parentheses represents the growth or decay factor, but the number specifically being added to or subtracted from 1 represents your growth or decay rate, which is what we found in the purple writing on this problem. So I hope this video was helpful in finding the growth or decay rates on these problems. And if it was, please give it a thumbs up, and you're now ready for exercise number 3. You can click on the link in the video provided. Thank you for watching.